Hello friends, my name is Shiv Prakash Singh and welcome back to our channel BI&DataScience.com. In today's video, we are going to learn about the mathematical and statistical foundations behind machine learning and AI algorithms. This would be a 5-part series and you are watching the first part. We'll cover about descriptive statistics, learn about what are the measures of central tendency like mean, median, mode. Then we will learn about the measures of spread like interquartile range. We'll also learn about outliers, and we will learn metrics like standard deviation, variance, mean absolute deviation, a basic introduction to probability and what random variables. In part 2, we will learn about the distribution and inferential statistics. So we will learn what are different kind of distributions like binomial distribution, normal distribution, and what is a hypothesis testing, type 1 error, type 2 error. In the third part, we will learn about the mathematical foundations, vectors, matrices, eigenvalues, what they are at a very intuitive level from a logical angle. Part 4, we will learn about the basic calculus, commonly used algorithm in all machine learning, gradient descent. In part 5, we will put all this together to comprehensively understand how an algorithm works. We will learn a little bit more about correlations, regressions, causality, and predictive modeling. Based on all the feedback that you will provide us and your engagements in the first 5 series, we will make a decision to make a 6th series, which will be the bonus part, and that would include concepts from business perspective, including Bayesian statistics, A/B testing, design of experiments. Also, put all your thoughts in comments, what other things you would like to be covered, and we will try to incorporate them as well. So don't go anywhere. It will be a fun session and I'll be back after a very short intro. Let's dive into understanding the measures of central tendency. So, measure of central tendency is you are trying to represent a group of number or the gravity of the group of numbers by one number. Let's take your sleeping example. Suppose the question is asked today, how many hours did I sleep in last 7 days? So the idea is you have -1. This is 2 days back. This is 3 days back, 4 days back, 5 days, 6 days, and 7 days back. Now suppose I slept 8 hours here, 7 hours here, 5 hours here, 6 hours here, 4 hours here, 7 hours here, and 6 hours here, right? In this example, if I am asked, what number can I give that would represent my sleeping habits? One way that people would do is, okay, let's find how many hours did I sleep, right? Total. And what you do is you add all of this. So that would be 6 and 4 is 10, 7 is 17, 6 is 23, and this is 28, and this is 36, and this is 43. So I slept 43 hours. Now I slept 43 hours over 7 days. So if I divide by 7, this would be my hours that I'm sleeping every day. So that would be close to 6 hours, right? 6.1, something like that. So I can tell that person one number, okay, I sleep 6 hours. My sleeping habit is 6 hours. Now this number is very commonly in our everyday life, we call this number as the average. So I would say on an average, I sleep 6 hours on a daily basis. This may seem easy, but when you tell it intuitively, you're not being precise, right? So your brain picks a number that is the most obvious guess. So most of the time, it might be you are telling a very close guess, but when we are dealing with the actual data and the decision making is dependent on the analysis, we have to formulate all of these representation in a more mathematical and in a more accurate way. So we will understand the intuition. I will not go too much into the formulas and math because all we are trying to understand is the concept. So this concept is called average. Average, or more mathematically it's called as mean. Now what is mean? You add all numbers and you divide by the count, right? So here we added all the numbers and we divided it by the count to get the average. So in mathematical terms, all these data points are an instance of a variable. So if sleep, or number of hours of sleep is my variable x, then 6 hour is one value for that variable. So this is called x1. This is my second value of that same variable. This is my third reading or third value for that variable. This is my fourth reading. This is my fifth, and so on, right? So I have 7 instances of x, or I have 7 readings for the variable x. So to generalize, we generalize is with this term xi. Now here x is the variable and I is the instance. So x1 is I is 1. So to find the average, what we are doing is we are summing up. This is a short form to say I'm doing x1 plus x2 plus x3, all of that. It's I'm summing all the instances of x, and my I is 1 to n. Here n is 7, and then I am dividing it by n, the number of observations. So this is my average or mean. So this is one measure of central tendency. Now there can be another measure. So the other thing would be, if I have to tell how many hours is my sleeping habit, all I can do is I can take all these numbers and I can arrange them. So if I arrange them, they will look something like this: 4, 5, 6, 6, 7, 7, 8. Okay, 2, 4, 6, 7. Yeah. Now I can take these 3 numbers and then I can pick the middle one. So I can say my sleeping habit is 6 hours. Now this way of finding a number to represent the whole group is your median. This is called as median. So how do we find median? We arrange the number either in descending order or ascending order, does not matter, because we'll have to find the middle value. So from whichever side you look. So we arrange the number and then we pick the middle number. That's my median. Then third way of representing, this is my mean, this is my median. Now I have to find another way of representing, and that other way is called mode. Most oftenly when you ask people, they guess based on mode. So you may remember what is more frequent, how many hours you sleep. So if you are sleeping more number of days, 6 hours or 7 hours, that number will be the first guess in your brain, because our brain works on the law of aggregation and law of generalization, and our brain picks up the most common, the frequently used number. What do you remember? Things that you read very often or you revise more. You'll remember that. What skills do you master? Things that you do more. Those are your strength. We call them strength, but technically is your brain remembers things that have more frequency, which is mode. So in this data, actually we see 6 is 2 times, 7 is 2 times, and everything is 1 time. So if you have, there can be two modes. So suppose if this was 6, then we have 6 maximum number of times. So our mode would be 6. But now because we have 2 6 and 2 7, we can now take the average of those 6 and 7 and we can say the mode is 6.5. Because my data is two model, I have two modes in my data, which is possible. We also call it in data analysis the camel hump. You see the camel hump is one neck and like this, M kind of. Third way of finding a representative number. Now, if you want to look at some example of multi-model distribution, so here you can see in this data, here we have one mode, here we have two modes, and here we have three modes. So this is my unimodal data, this is my bimodal data, this is my multimodal. So you can have many modes in your data. But mean and median, you will have one. You will not have many means and many median, because mean you are calculating by adding everything and dividing it by the count. You will get one number. That number will be decimal number or it can be an integer, but you will get one number. Median, if you arrange anything and if there are odd numbers that you are arranging, you will always find one number in the middle. But if it's an even number, then you take the average of two middle numbers. Same thing is with mode. If you have many modes, just take the average of your different modes. Now, these are some ways of representing your data. Now, the question comes, which is a better method? What should I use in real life? So to understand this, before we come to here, let me explain one more thing. So most of the time in data analysis or business intelligence, what we are dealing is a trade-off. So what we are dealing is a kind of a trade-off. So here it's a scale, right? On one side we have precision, and on the other side we have the information. Now precision is, if somebody asks you how many hours you sleep, you give him all the data points. You tell him 8 hours, 7 hours, 6 hours, 5 hours, 4 hours. You made a record. Don't tell any guess number. But if you have recorded your sleep using some sleep tracking device and you give him all the data, your precision is maximum. It's as precise as it can be, because that's the best what we measured. Now there can be measurement error and all of that. That's a whole different thing. But to the best ability, it's 100% precise data. But it is too big to comprehend or understand. So there is very less information. Now, when you are trying to put all those numbers and you are trying to represent it with one number, you are losing a lot of precision in middle. Because if I am sleeping 8 hours, 7 hours, and 9 hours, my average would be 8. But I am losing. Someday I am sleeping 1 hour less, someday I am sleeping more hours. So there is some loss of information because I am generalizing. So this is loss. But what I am gaining is clarity. I am getting more information. So business managers or CEO of your company will have more information if you tell him one number, like our average sales is X, or our average sales is 5 million, 10 million, 1 billion. It's easy for him to make decisions on, rather than you throw him Excel with 1000 rows or 1 million rows. You may be precise, but there is less information. So what happens is, if you look at this trade-off and now go back to our measures of central tendency, which metric do you think conveys the maximum information, even though if it is represented by one number? In most of the cases, mean represents the maximum information. Why? Because it's taking into account all the numbers. It's picking the information from all the numbers because we are using all the numbers to add up and then divide. So the maximum information is captured. Whereas for calculating mode and median, we are just picking either the most occurring number or the number in the middle. So it's ignoring what these values may be and what these values may be, right? For example, suppose you give an exam in 5 subjects. Suppose you gave an exam in 5 subjects, you scored 99 in 2 subjects, and you scored 81, 81, and 82 in 3 subjects. Now your median would be 82. Does this represent your intellectual level, or does this represent the level of your knowledge? Probably it's underrepresenting because your average would be somewhere around 90. It's ignoring the fact, like the higher numbers, you got really 99 in 2 of the subjects, right? It's not taking into account whether this is 90 or this is 91 or this is 95. It does not matter. There is less information in that variable. The other number, if you look at mode, the mode would be 81. Again, does not reflects your true intellect. So from information perspective, mean carries the best trade-off between the loss in precision and the maximum information. However, there are situations you can say. The challenge would be think of situations where mean would not be a representative number. So in this example, suppose this is your sleeping habit. One day you are not feeling well, you were sick, and you slept 16 hours that day. Now if you try to take the average of 16, 7, 4, 6, 5, 7, 8, this number will bump up. This will come to something like 9.1 or 8.5. Like it will be much higher than 7, 6.1, which was your average true sleeping habit. There are too many outliers, then mean becomes biased because it's pulled away by those. And we will talk about what a bias and what a consistency is. May not be in this series, but when we learn machine learning and more sophisticated algorithms, then there is a similar to precision and information. Whenever you are running a machine learning model, you do a trade-off between bias and consistency. So it's a similar concept, but little bit different. So outliers are your data points which are far away from rest of the data. And when your data has those challenges, mean will not be a good representation because it will be pulled away. So your mean will come something like here. Your mean may be, now your new mean may be here. Which is not the representation. This is no longer representation of these data points, right? So in this scenario, median is a much better alternative because if you arrange all of them, then the middle number will not move too much. So if you add outlier here, the middle number may move by 1 spot or 2 spot, which is again within the group that you are trying to represent. If you add outliers on the lower side, if you have 2 low numbers, if you get 2 low numbers, then also your median doesn't affect because it may move 1 or 2 points this side. So median becomes a much better alternative of measure when you have outlier in your data. And mode is better whenever you are dealing with categorical data or data that is expected to behave in a certain way most of the time. For example, price. If you are trying to track the base price of a product and a store is selling some days of the year at a higher price whenever there is more demand, and some days whenever there is festival, or whenever there is a slow season, the shopkeeper may give a discount. So the price will have fluctuation, but most of the time it will be sold at a fair price. In all those scenarios, mode becomes a much better measure of central tendency or representation of the data. So I think you have now a very good understanding of the central tendency. Now let's move to the spread. So looking these two set of numbers, you see the mean is same. However, in the first set of observations, it's much tighter data because my entire thing is spread around 100. My minimum value is 98. So this entire thing is spread between 98 and 102. And this thing is lot spread. So if I have to draw, the first set of number is 98 to 102 with a mean of 100. And my second data is spread all the way from 40 to 200, again with the mean of 100. So this is a situation, and again this is not an outlier situation, it's just the data is spread apart. It's like a rubber band, you stretch the rubber, and here all the data points are in a close compact. So if these are two, say, cricket players, then this player is more consistent, this player is having a wider spread, their average is same. So but this player would be more reliable. If you have to bet, you'll always bet your money on this player, right? Because he always scores around 98, at least in 90s. This person can go 40, 60, 50, any number, right? So when you are trying to represent a group of number with one number, either we use mean, median, mode. We saw mean carries the maximum information, but even then alone it is not sufficient to give us the whole picture of how the data originally was. But if we give in some way the information about the spread of data along with the mean, then we can make a better picture in our mind. We can think of where the data is centered, like the gravity, where the gravity is, along with how stretched the data is. So to represent this stretch, we call it as dispersion. One way of telling the spread is what we saw. You look at the mean value and you look at the max value, and we take the difference between mean and max. Often this is called as the range. So range is one measure of a spread, which is nothing but your min and max difference. So the difference between your max and min. It gives you a good idea about how widely or how narrowly spread your data would be. The other way of representing, now this again, there is a better way of representing this data. What if I knew all my data, like rather than just knowing the minimum and maximum, I also knew how the data was spread in the middle, probably something like this. So this is my data, I know the min, I know the max, right? And then I know where does my first 25% of data lie, then my another 25% of data, and then my third 25% of data, right? This is my max, this is my 75th percentile, this is my 50th percentile, this is my 25th percentile, and min is my 0th percentile. So if I can tell you now three numbers: min, max, and what is the difference between the second and the third range, between the second and third, then I have more information about my spread, and this is called interquartile method. Now, something that you will obviously do a lot in your study is most of the software programs, if you do them to do a box plot, they will do a box plot like this. So this would represent your minimum, this would represent your maximum, quartile, which is the 75%. This represents my first quartile, which is my Q1. And obviously, what would be the middle? Middle is always median, that I already know. So by knowing the minimum, maximum, interquartile range, and your mean, so by knowing a set of 5 numbers, I can now get a lot more idea about my data. So if there are 1 million data points, does not matter. My data now can have 1,000 points. My data can have 1 million data points. So I can look at a sales of 100 days, 500 days, 1000 days, doesn't matter. If I know 5 or 6 numbers, the average daily volume, the minimum, maximum, interquartile range, and median, with a combination of these 6 numbers, I have a fairly good picture of how my sales distribution or graph looks like in my brain. This is the beauty of data analytics. And to be a good data scientist and good data analyst, you have to practice visualizing these numbers for a lot of variables, and you can start practicing in your daily life. Whenever you are going in the traffic, just try to assume, if I have to think of the average number of cars on the road, what would it look like? Average number of commute time every day, how does it look like? Or how many hours a person is working in the office, how many breaks they are taking. Like, if you can use lot of real life examples to build a graphing capability in your memory, and this will help you become a good analyst, because then in real world you'll be able to visualize sales, conversion, lot of metric. Anybody gives you 5 number, you'll be able to think of how that number is distributed. Now let's move on. So our journey is yet not over. We are still missing one thing in the distribution, because by knowing the min, max, and interquartile, I know the spread of my data, and by knowing median or mean, I know the center of gravity, or I know the central point that is representative of the entire data set. But what am I missing? Actually, I'm missing the variation. How the data is now varying, like how are the data points here? Are they very close from the mean, or they are far away from here, right? So what I'm missing is how my data is spread around mean, right? And this is called variation. So remember, we had x to represent the variable, and every instance of x was xi, and then we said, let's call x bar as the mean, is nothing but you add up all the xi and you divide it by n. This was your mean. Now once you have your x bar, I want to understand how is my every xi different from my mean, right? And if I add all of their difference from the mean, and okay, this is an interesting question. Think about it. If I add the distance of all the point from mean, what would the number be? It would be 0. Why? Because mean is my center of gravity. So it is kind of trying to balance. So any number, some numbers will be closer and some numbers will be farther. But if I add the distance of all the number around mean, the total variation will be 0. That's why all you have to do is you have to balance by taking the absolute value. So now if I figure out how far is my each number from the gravity, but I am not negating the positive and the negative variation. I take positive variation also as a variation, negative variation also as a variation. So I now add the total variation, right? So that's why, because we are learning about variation, right? Our topic is variation. If I get all the variation and I divide this by n, this kind of represents a degree of this will give me a good understanding of plus minus how far is my each point from the mean, and this is called as MAD, or mean absolute deviation. Now this is one way to think of. The other method of calculating variation is I know my xi's. I know all if I take the difference of xi from x and I square this to take care of the positive and the negative differences, and I sum them all and then I divide it by n, then this is called my variance. This is very commonly known as variance. This is variance. So one way of measuring how far apart the numbers are is by taking the absolute difference from the mean and taking an average of those distance. So it's the mean absolute deviation. Or the other way would be to see how far is each point from my mean, take that distance or that difference, square it. So rather than taking the absolute value, I square it to make sure it's positive. That's variance. But again, this will be a big number. It will not give you any intuitive understanding about your data. So for that, what we do is we take the square root. Because we are squaring, if we take the square root, then what we get is the standard deviation. And standard deviation gives you a very good idea of how is my data distributed. For example, if your mean is say 100 and your standard deviation is 10, it means my data is plus minus 10 points away from 100. So somewhere most of my data points, 66 or 68% of my data points will be between 100 minus 10 and 100 plus 10. And if I take 2 times the deviation, which is 100 plus 20, 100 minus 20 and 100 plus 20, then I will have roughly all my data, 99% of my data will be in that range. And this kind of distribution is called normal distribution. And this is the distribution that we want to deal in the real life. and most of the time most of the variables do follow normal distribution. And if they don't follow normal distribution, there are ways we call it normalization. We can normalize our data to kind of make it fit into a normal distribution. So what is a normal distribution? A normal distribution is something like this. So these are your values of data, right? And this is your mean. This will be your, these are my values of x. This is nothing xi, and here it is the frequency. And we are talking about millions of data point or thousands of data point. So most of my data point would be here. And if this is my mean plus we write standard deviation like this, right? So mean plus standard deviation, this will have around 68% of my data. And if I take 2 standard deviation, then this would be my 98% of the data. So that's the benefit of knowing your variation. So if we know the mean, median, spread and variance, whether standard deviation or mean absolute deviation, then in our head we can visualize that data, how it is, it would be spread, how it would look like, what distribution it would be. It gives you a lot of value. That is the importance of understanding the measure of central tendency. Now you have to practice it, visualize it, and you'll be able to comprehend a lot of data points from here. Let's quickly learn about probability and random variable, what they are, and we will be good for the session. So probability is nothing but it's the chance of something happening. So if you flip a coin, you get head or tail, the chance of happening is 50-50, because a 50% chance you can get head and 50% chance you can get tail. So what would be a general definition of probability? So we say probability is nothing but number of odds or events in your favor, by total possible outcome, right? That's a probability, right? For example, if I have a dice, I have 5, 3 and 2, I roll the dice. What is probability of getting, say, a number, any number? What's the probability of getting 6? So all I can get on a throw is 1, 2, 3, 4, 5 or 6. So probability of getting 1 is also 1 by 6. Probability of getting 2 is also 1 by 6, and probability of getting 3 is also 1 by 6, right? So all of them come, it's called an equally likely chance. They all have equal chance of showing up. So I have 1 by 6 chances of getting 1 or 1 by 6 chances of getting 6. You add all of them, it will become 6 by 6 or 1. So what does it mean? 1 means it's a guaranteed event. So if I roll a dice, I am guaranteed to get a number between 1 and 6, right? So now if the question is what's the probability of getting a number more than 4? So more than 4 are how many? Two numbers. So number of events in my favor are 2 because I have 5 and 6, right? So two numbers in my favor, total possible outcome are 6. So probability of getting a number more than 4 would be 2 by 6 or 1 by 3 or a 33.3% chance, right? Now, let's make it little complicated. Now, if I roll 2 dice, okay, suppose there are 2 dice, then first let's find what's the total possible outcome. How many outcomes can happen? I can get 1 on first dice and 1 on second dice, or 1 on first dice, second on dice, so on. 1 on first dice and 6 on second dice. So this is for all possible 1 on the first dice. I can get any number from 1 to 6 on the second dice. Similarly, for first dice I can get 2 and I will get all the 6 possibilities of getting any number on the 6 dice. Similarly, I can get all the way 6, 1, 6, 2 and 6, 6. So these are 6 outcomes. These are 6 outcomes and I have 6 times. So I have 6 times 6 outcomes, that is 36. So my total outcome is 36. So if I roll 2 dice, I can get any number, any combination of number from the 2 dice, and that total number of combination is 36. So my all possible outcome is 36. Now the question would be, what's the probability of me getting a number more than 12? So I'll have to find all the events that would be in my favor. So I can get 12 if I get 6 and 6 on both dice, or I can get, that's the only possible. I cannot, there is no other way to get 12. So to get 12, my probability is 1 by 36. Right? Now, what is the probability of getting anything more than say 9? Then I will have more options, because then I can get 5 and 4, or I can get 4 and 5, or I can get 3 and 6, or I can get 6 and 3, right? So that is 5, 4, 4, 5, 3, 6, 6, 3. Any other way to get 9? Oh, no, I don't think there is any other. So there are 4 possible cases. So getting anything more than 9 would be 4 out of 36 or 1 by 9. So this is basic introduction of probability. So what's the likelihood of, what's the total number of favorable cases divided by all possible cases? That's your probability. Now, a lot of time what we would be concerned is about understanding what is a random variable. So a random variable is nothing but it's a way of representing probabilities to a variable that can, so I have a variable x, with what probability it can take a value from a given set of values. In that case, I call x as a random variable, and for example, in throw of dice, x would be the outcome and the possible values would be 1, 2, 3, 4, 5 all the way to 6. So x is a random variable whose values can occur from 1 to 6 with a probability of 1 by 6 for all of them. Now, why do we need to understand random variable? Because random variables help us quantify the uncertainty. So we figured out a way to represent massive amount of data using 5-6 different numbers, which is the central tendency measures. And after understanding the distribution, if we can understand the likelihood or probability of something happening from that whole space, that will give us a big picture of kind of playing with scenarios. So random variable help us quantify the uncertainty, and it also helps us predict and simulate real life scenarios. This is an introduction. I wanted to give you the basic understanding of statistics. This is part 1. If you like this video and if you have learned something new, please like, share and subscribe to the channel. If you guys give us a lot of likes, we will bring the bonus to the series. Thank you for watching. Stay safe.